In this video, we're going to learn about temperature and energy and the important characteristics of these two different ideas. Most simply put, temperature is a measure of how hot or cold an object is. And we have two different scales that we will use in the scientific community. One is the Celsius scale, and that's based on measuring the temperature at which water freezes, which is 0 degrees Celsius, and then the temperature at which water boils. This is at sea level. Standard temperature and pressure. At 100 degrees Celsius, we take those two temperatures, we divide it by 100 even points, and that's what a Celsius is. Another temperature scale that we use in scientific community is the Kelvin scale. So it's an absolute temperature scale. So you have 0 Kelvin, which is absolute 0, and that corresponds to negative 273 degrees Celsius. And you cannot have negative temperatures on the Kelvin scale. 0 is the lowest temperature, and then it goes up from there. If you want to convert between Celsius and Kelvin, if you have the Celsius number, you add 273. If you have Kelvin and you're trying to get Celsius, you subtract 273. And one thing to note is that a change in Kelvin is the same as a change in Celsius, because the magnitude of 1 Celsius is equal to the magnitude of 1 Kelvin. So they're the same size measurement. It's just the starting point is different. Now, a bit more specific definition of temperature is that it's related to the average kinetic energy of the particles. So when you're thinking about the word temperature, you want to be thinking about the particles and the molecules moving either more quickly or more slowly. And so when temperature is raised, it means the average kinetic energy of the particles goes up, so the particles are moving faster. And if you see on the right here, that's a temperature scale, and this is a Kelvin scale. And so 0 Kelvin corresponds to when the particles in the substance have no kinetic energy, which means the particles are no longer moving. So that is what the temperature Kelvin scale is based off of. So the average kinetic energy of the particles and the temperature are proportional to each other, and they follow this equation here. And so the EK with the bar over it, that's the average kinetic energy. So that is the kinetic energy of the average particle. So it's a very small value. It's multiplied the temperature by the Boltzmann constant, and you can see the Boltzmann constant 1.38 times 10 to the negative 23. So that's a very small number. So if you wanted to find the total kinetic energy inside a substance, you'd multiply by the number of particles. It's important to be able to distinguish between temperature and heat. So those are two different concepts here. And heat is thermal energy, and the word heat, those are interchangeable. And so thermal energy or heat is the transfer of energy between objects at different temperatures. So you want to start thinking temperature is how fast the particles are moving, whereas thermal energy is the transfer. So it's the amount of energy transferred between objects. Heat always transfers from a higher temperature object to a lower temperature object until they reach a point of equilibrium where they both have the same temperature. Another concept is internal energy. And so this is different from heat and temperature. And so we call internal energy is the total energy in an object. And by total, I mean we add all of the potential energy from the intermolecular forces, and then we add all of the random kinetic energy of the molecules. And so if we add those two values together, we get what's called the internal energy. One way to think about internal energy is to look at this example of the sliding block. And so we have a block, we're applying a force, there's a force of friction, and the block is traveling at a constant velocity. So the applied force and the frictional forces are equal, forces are balanced. Now we want to just look at the definition of work. And so work is the energy transferred to an object by applying a force. So we are doing work in this case because we are applying a force over a distance. And so there is energy being transferred to this block. And now we have to think, well, what is the energy being transferred doing? Is it increasing the kinetic energy of the object? And the answer is no, because it's traveling at a constant velocity. So we're not increasing the kinetic energy. It's just remaining the same. It's also not increasing the gravitational potential energy because the block is not moving up or down, it's on a flat surface. So this work that we are doing, this transfer of energy that we are creating, where is that energy going? Because we know that energy is not created or destroyed. So the work that we're doing in sliding this block, it must be going somewhere. And it turns out what's happening is the internal energy of the block and technically the floor are increasing. So the friction is causing the particles to rub against each other, therefore increasing the kinetic energy of the individual particles, which increases the internal energy of the block. And you would have experienced this, when you rub objects together, you can feel the warmth between them. Friction creates warmth. It creates an increase in temperature. And so that example of the sliding block is a really good illustration of how you can apply work and apply a force. You don't change the kinetic or the potential energy of the block itself, but you do end up increasing the internal energy of the particles inside that object. So in summary, it's very important to know these definitions. First, temperature, you want to think, is always related to the kinetic energy of particles. The Kelvin scale is absolute, so absolute 0 is the lowest temperature, and it builds up from there. When you have a change in Celsius, that's the same as a change in Kelvin, because the Celsius and the Kelvin magnitudes are the same. The thermal energy is the transfer of energy from hot to cold objects. And internal energy is the sum of the kinetic and potential energy of the particles. So these are the main definitions you need to know to have a better understanding of thermal physics.